We have a full house today here at the Renaissance Computing Institute, so we're very excited. So welcome to the inaugural South Big Data Hub Data Science Roundtable. For those who may be wishing to live tweet this event and quote Chiton, please use hashtag SBDH16, South Big Data Hub 16, or hashtag BDHubs. I'm Dr. Leah Shanley, the co-executive director of the South Big Data Hub here at the Renaissance Computing Institute at beautiful North Carolina at Chapel Hill. For those of you who may not be familiar, the South Big Data Hub builds R&D communities of practice and accelerates partnerships among government, industry, and academia for those who apply data science and analytics to help solve regional and national challenges. The South Big Data Hub is part of a network of 4 hubs launched by the National Science Foundation in 2015 and co-sponsored by our host institutions and other partners. We manage the South Hub jointly with Georgia Institute of Technology in Atlanta, and we serve 16 states in the South region, everywhere from Texas to Delaware, and everywhere in between, and have 500 members from universities, nonprofits, corporations, foundations, communities, and communities of practice. Before we get started, I'd like to introduce Dr. Stan Aholt. He's the director of the Renaissance Computing Institute and one of the 2 principal investigators on the South Big Data Hub. Thank you.
Thanks, Leah. I'm so pleased to see everybody here in the room, and then also hearing all the beeps as people come online. Would you estimate, Stephanie, how many people are online at this point? Guess. 35 or 40 more people, and 36. So we're going in the right direction. So it's my great pleasure to introduce Chetan Baru from NSF. He's currently on assignment as Senior Advisor for Data Science in the SISE Directorate at the National Science Foundation. I've known Chetan for a long time. He's a wonderful colleague who does very interesting research and scientific research himself. He's the Distinguished Scientist and Associate Director of Data Initiatives at the San Diego Supercomputer Center, and that's part of UC San Diego, and he works on applied and applications-oriented research problems, all of which are related to data management and data analytics. He's been part of a lot of national initiatives. He was PI of the Open Topography Project. He was part of Cyber Infrastructure for Comparative Effectiveness, SciCore, NEON, NIS, Quasi, GEON, the list goes on and on. Needless to say, he is an incredible asset for NSF. NSF has been steered with his leadership, and we're very pleased to have him come down to Chapel Hill and give this talk. And tomorrow he's over at RTI giving another talk, and we will be in Durham for another South BD Hub initiative with the Data Start group. So I welcome everybody here. Thank you so much. Just a reminder, as you come online, please do mute, because we'll hear you typing or eating or doing whatever else you're doing. So thank you so much, and with that, I'll turn it over to Chetan.
All right, Stan, thanks very much for that very gracious introduction. Thanks to all of you for turning up at the lunch hour. But it is beautiful here in North Carolina. I can see green all around here. I just wanted to say that the beeps are also when people exit. So it's not just entries. So they may all be just leaving right now. Okay, so I think I'm going to take about 35 minutes to just give you an overview of this whole area of harnessing the data. So harnessing the data revolution, it's one of the sort of big ideas that NSF has recently put out. So first the outline of my talk will be just mention what the NSF big ideas are, talk a little bit about current data programs, and then try to spend more time about future directions, that is, where should we go from here. And as Leah mentioned, I'm open to having discussions, Q&A, and so on. Clearly, the ideas are formulating. We are not saying things are cast in stone here, so we are open to listen to input about all of these things. And obviously, you are the folks who are doing the real work. You're at the cutting edge, so input from this community is very important. So this is just the SISE organization. Computer Science Directorate is one of the 6 or 7 directorates at NSF. There are 4 divisions. ACI, CCF, CNS, IIS. I won't expand all the acronyms. There'll be more acronyms during the talk, don't worry. I'm assuming you're all familiar with this. And where that person is blanking out is another of my colleagues, Peter Arsberger. So there are two of us, Peter and I, as senior advisors in the SICE directorate. So the NS of Big Ideas. This is something that was recently put out by NSF. Hopefully you all had a chance to see it. The goal was to come up with a set of really exciting initiatives that would catalyze investment in fundamental research at the federal level, generate broad public appeal, attract partnerships with industry, private foundations, and academia. So multi-sector. By the way, I should also say that I'm very happy to be your inaugural guinea pig for this South Big Data event that you're trying to do. And I'm reminded of that because when we talk about partnerships, the Big Data Hubs program that we have created is exactly about partnerships. Also to put forward the agenda for cutting edge research that would be the appropriate kinds of things for NSF to do. The process by which this was arrived at was each directorate had discussions about what they thought would be these big ideas for the next 5, 10, 15 years from a directorate point of view. And these were all bubbled up to an assistant director AD retreat that happened across all the directorates. And then these were filtered down to these set of ideas that you're seeing through refinement and collaboration across directorates. So here are the ideas. On the top are the 6 big research ideas. Obviously, data is in the middle. Actually, left to me, I would have been happy if data was the only big idea, or one of the few big ideas, and everything else was connected to it. But there are 6. Navigating the new Arctic, work at the human technology frontier, understanding the rules of life, so basically from genotype to phenotype, the quantum leap, so the next revolution in quantum computing, and then windows on the universe, multiple ways, mechanisms that we now have for trying to discover the universe. And data science is in the middle, and actually you can already see that many of these, if not all, actually have huge data requirements as well, right? So they will be, in fact, connected to the data theme. There are also some process ideas, and these are more to do with how NSF would do its business, go about doing its business. So the notion of convergent research is that in each of these, in almost any problem that we are looking at, that the community is faced with and we are looking at now, we have interdisciplinarity. We have a lot of disciplines coming together. So there is this notion of convergence, and the notion that problems that we are looking at, whether it's smart cities or climate change or precision medicine or public health, etc., all really need a holistic view, which means multiple disciplines coming together. So the process idea there just says that NSF sort of recognizes this need, which might imply that future programs that may come out will have more and more of these interdirectorate kinds of initiatives. The other second process idea is to how do we do programs that increase the diversity in science and engineering, which is always an ongoing challenge. The third one is about this notion of mid-scale. So if you look at NSF today, the standard programs might get up to, say, $20 million or so, if they're the big STC and those kinds of things. And then there are the major research equipment projects which start from around 200 million or so. So there's this gap between 20 million to 200 million where there could be a lot of interesting work that could be done, but there's really no sort of vehicle to make that possible. So that's the identification to say, let's create some mechanisms in between, say in the $50 to $70 million range that we could have programs. And that's very relevant, of course, to the big ideas and certainly for the harnessing the data idea that we're going to talk about today. And then the last one is about creating some kind of an innovation fund that would be at the discretion of the director. This would be to jumpstart new areas very quickly and so on. So those are the ideas. And they're all very interconnected. So this circle shows on the left-hand side are all the big ideas, on the right-hand side are all the directorates, and the lines are just saying that they're all connected, as you can see with the jumble. But if you look at the harnessing the data idea, it connects to actually all the directories. So that's important. Everybody would be interested in that. And then if you look at also size as a division, it has links to all the ideas. So as computer scientists, of course, that's very interesting and exciting for us. So that's really all that this is about. It's a very interconnected thing. So in any of these ideas that we push forward, it has to be a multi-directory effort, not just a single directory going forward. So now let's talk very quickly about existing programs that NSF has. So when we look at in the data area, so when we look at our data science and data programs in general, we like to use this quadrant diagram to show the sort of 4 basic areas in which investments are being done. One is, of course, naturally foundational research. The other is cyber infrastructure. Third one is education and workforce development, and then collaboration and partnerships. And overlying all of that are policy issues such as open data, data sharing, and so on. Okay. I won't go through all of these, but I'll just sort of show you the names here, and some of you may be familiar with some of these programs. So the Big Data Research Program, which actually I have a hand in helping coordinate, it's actually cross-foundational. We have many program officers. Sylvia Spengler in IIS is a big helper on this, and we have other colleagues from every directorate. We have folks involved in this. But that's something I'm more familiar with. And then there are these other programs that we also have, which are all on the foundational research side. On the cyber infrastructure side, I'm sure you're familiar with these. I'm guessing you've received grants from some of these programs. So there is CC Star, which is the campus cyber infrastructure. There's DIBS, and some of the directorates have their own, or at least in the past have had their own CI kinds of initiatives. And the most important sort of education and workforce development activity is the NRT, NSF research traineeship programs. In the past, it has actually explicitly had a data science track. But data science always continues to be an area of interest for that program. And finally, this is a new area for us, and in collaborations and partnerships, it's our BD Hubs and Spokes program that we are very proud of. And thank you all for doing a great job of it. And everyone talks about this everywhere when we're on the road. So I think it already looks like it's going to be a program that's going to be quite successful and impactful for the goals that it has, which is really to create these multi-sector collaborations and help jumpstart or nucleate new activities that could then become bigger proposals or bigger other activities. Okay, so that's I think all I'm going to say about the programs. Now, cyber infrastructure is a key component, of course, in any of our strategies for data investments going forward. The other thing I wanted to mention is at the federal level. Again, this is by way of just giving you some quick context. There are multiple interagency coordination groups in different technical areas. It's part of the White House Office of Science and Technology Policy. One of the coordination groups is in big data. That's an interagency working group that I co-chair along with my colleague Alan Deary, who's actually right here in North Carolina. He's the associate director for NIEHS. And we put out a report back in May of this year, just laying out what are the issues for federal R&D in big data. I just wanted to point out what came out as the 7 topic areas, which should all again look sort of familiar to you. Creating next generation capabilities, that's the foundational research aspect. Understanding trustworthiness of data, and in fact we were just having some conversations about it earlier this morning. That's a big issue when you start using data for all sorts of decision making and for science and so on. Building the big data cyber infrastructure. Then the issue of sustainable preservation. How do you, as more and more data is being accumulated, what do we do with the sustaining the resource properly? A big issue, of course, is privacy, security, and ethics. Improving the education and training, as I'm sure you're all very familiar. Almost every university of any size is looking at starting programs in data science, whether the undergrad level, master's level, PhD level, and so on. There's a huge demand for these kinds of skills right now in industry. So how do we do things in the short term, but also what's the long-term strategy here? And finally, creating and enhancing connections in the Big Data Innovation Ecosystem, and once again our hubs and spokes program from NSF point of view responds to that. Again, note that this is a federal thing, so it's meant for all agencies to consume and do as they wish with these recommendations. So different agencies might have different programs that respond to different aspects of this. So coming back to the harnessing the data theme, what it sort of highlights is research across all of the NSF directorates. As we saw, there are interconnections from harnessing data to all directorates. We think of this three-circle diagram as showing the key activities that would be involved in this area. So one is just the theoretical foundations of data science. Right? So that involves maths, statistics, and computer science. Right? So how do we develop the theoretical foundations? The other is the systems foundations. How do we develop those systems that do the end-to-end management of the data? So data-centric algorithms and data-centric systems. And the third is what we call data-intensive research. This is research with data in all of the domains. So it may be biology, data-intensive biology, data-intensive geoscience, and so on and so forth. So those would be the key sort of areas in terms of the research. But there's also education is a big aspect of it. And then, as I said before, there has to be some cyber infrastructure that supports the ecosystem and the work here. Okay, so cyber infrastructure that's tuned towards the kind of data science research and the whole sort of explosion in data science that we are witnessing, even as we stand here. So if you think about this sort of in a geeky architectural way, like computer scientists, right? So you think of a layer diagram for how we might architect an open national infrastructure that would support this harnessing the data theme. You can think of the core infrastructure at the bottom. There are some services in the middle that allow you to sort of exploit that infrastructure, and then there are the applications that are essentially gateways into that set of services and infrastructure. The infrastructure clearly has to be storage and compute, right? So it's not just about a bunch of disks or tapes that are storing the data. There has to be compute that goes alongside with it. And so it's storage and compute together. It could be highly distributed across the whole country, whatever it is, whatever the architecture is. So as I say, there could be multiple stakeholders or multiple partners that would get involved in doing this. The scale at which this kind of activity is going on, first of all, there's already activities underway all over the country. And secondly, NSF is not saying that we are the only ones who can do the whole enterprise. It's too big for just NSF to do it. So there are partners from the campus level. There may be regional partners, maybe regional in the south or the west or Midwest, whatever it is. There's clearly a role for commercial folks here. Could be the cloud providers or others. And there could be national things which, again, folks like NSF could help with, maybe NIH. And certainly there are international activities that you might want to link up as well. One of the substrates that we might exploit here is the sunk infrastructure that NSF has already funded in the terms of, in the form of CCNIE, this high-speed networking that is on campus and across Genie networks and so on. Those could form the physical substrate on which all of this gets developed. In terms of services, there are core services, right? Just basic things like authentication and distributed storage and access to data. But then there's a whole set of interesting services we could be developing that are related to discovery of data, access to data, deep analytics, semantics, integration in a very broad sense, and so on and so forth. So a lot of action potentially there. So, of course, as you go from the top to bottom, you get more sharing. So, stuff that's built here could be shared by multiple applications or multiple directed projects, and then more disciplinary emphasis in the other direction. A big issue in all of this, of course, will be things like governance, policy, and sustainability. How do we manage this infrastructure? What would be the policies of getting in and out, and so on and so forth. So that's sort of the broad context for it. But all of this should be created in the context of applications. And in the case of NSF, the applications are science and engineering research applications. So ideally what we would like to do then is to partner with some of the big national priority research areas that NSF has identified and essentially use them as customers for this, right? So UTB, NBO, that's understanding the brain and the National Brain Observatory, so neuroscience oriented. Infuse is the nexus of food, energy, and water systems. The third one is smart and connected communities. And then the MREFCs are these large facility projects like the Ocean Observing Initiative or the National Ecological Observing Network and so on. Ideally, to get the most bang for the buck and also to make it really interesting to do research in this area, all of this should be able to serve a general set of services. And in a way, I think we are trying, with this vision, we are also trying to get away from some of the siloing that has tended to happen so far, right? I mean, right now, the way MREFC projects are done is each project does its own cyber infrastructure. So the question here is, could we do something more generic that could be leveraged by a lot of projects? It only seems to make sense and also then allows us to focus on the more interesting things, right? If we can make these more common and take care of this, then maybe working on novel services would become the next thing that becomes available for us to work on. So this environment would be characterized by open data, open systems, and open source. I gave this talk last week at the University of Chicago, and Mike Franklin actually was in the audience and said, "You didn't say open source." So I said, "Okay, well, I shouldn't say just open source. It's open data, open systems, and open source." And Andrew Chin was in the audience and he said, "You never said privacy." So of course privacy is and a lot of the sharing is going to be very, very interesting and tricky because, I mean, there's a whole lot of NSF data where privacy is not an issue, like data about stars or atoms or subatomic particles. But the moment you have data about people or anything that's positional and spatially oriented, there are issues. So how do we tackle all of that? There's a good challenges to have. So, okay, let's talk a little bit about the future now. So, I'm a data guy, so I just love it. I mean, the data is, I can retire without any problem just working on data for the next number of years. Reagan has retired and he's still working on data. So I think there's plenty to do. But if you want to think in terms of what does the landscape look like, so one can posit that there will be this data-intensive aspects of computer science. That is, just like every other science, there are areas of computer science that are going to see lots more data. Internet traffic analysis is one, data center logs analysis is another, performance, and so on and so forth. Okay? But then we have this new discipline of data science. And the data science discipline is really about studying data per se, right? The whole life cycle of the data. And as I say here, there's the theory of data science, representational issues, modeling as in statistical modeling, but also like data modeling, all of those kinds of things. Statistics, machine learning, decision support, and then technological or pragmatic issues like workflows, reproducibility, and certainly ethics. Right? So if you put all of that together, that's a new discipline. Okay. I also like to think about translational data science. So translational data science then is the notion of applying data science techniques to solve real-world problems. Okay? So then there's a connection from data science to, say, data-intensive computer science. Right? You might have so much log data that you have to use Hadoop or some other statistical Hadoop with some statistical techniques to process it. So there you go. But similarly, you have data-intensive biology, geoscience, and all of the areas. Okay? So that's kind of the role that translational data science plays. And I think it's kind of important to have that concept because for decades in places like where I have worked before, I'm not sure about Renzi, but well, I still work, which is San Diego Supercomputer Center. There's always this concern about these professional class of folks who really make things happen, right? They're the guys who are doing the plumbing and who are really making sure that the HPC or the data stuff is happening. And there's no way to recognize them. Because in the university system, they're essentially transparent. Right? It's like contract workers at Microsoft. Sometimes like there's a controversy. you put people on contracts, they don't turn up much of money. You can just fire them. So calling out that this activity is actually a first-order activity, I think would be important. And I think just as you have translational medicine, this notion of taking things straight from research into clinical, is the same thing here. So a few years ago, I was trying to push this idea at my institute, SDSC, that I was actually a translational computer scientist. I couldn't convince the folks there. But I think translational data science is an important thing to think about. Okay, so how do we make progress? So one way that one mechanism that's useful for NSF is for the community to express needs in certain areas, right? So if you look at the traditional sort of science disciplines like astronomy, physics, and so on, they tend to get together as a community and identify what's the next big infrastructure that they need. The next big telescope, which needs to have this kind of storage system. It has to be able to accept petabytes at a time, and et cetera, et cetera. And that becomes sort of the vision for that community. So I think data science is at that point right now. Right? So data science as a community needs to be able to articulate what are the infrastructure needed to make a real big push in data science. Right? So identifying what are the needs of data-intensive computer science and data science. Can we have community? For example, the idea would be to say have community workshops to identify these needs. What are the needs? I think they go from everything from what are the hardware kind of platforms you need. What are the data sets? So the data set itself is part of the infrastructure. Right? You've got to have. I don't think I have that slide, but we now talk about. Maybe I do have it. I'm not sure. So I'll just mention it. We've been working in some topic that I'll mention in a couple of slides with some folks from industry. One of which is Guha, R.V. Ramakrishna Guha from Google, and he coined this phrase, the hello world for big data. Right? So we can't do hello world for big data in academia today. Right? Nobody is able to do that. The hello world for big data is, can you walk up to a petabyte and say, let's take 20 terabytes out of this and do some modeling with that 20 terabytes, and give that as a homework problem. Right? We can't do that. Whereas a lot of internet scale companies, they do this every day. This is what the data scientists are doing. So we have challenges like that. So data themselves are infrastructure, access to data. And then we might build standard software stacks we can use, and also distributed test beds. That is, something like smart and connected communities. There might be a test bed. There's this project called the Array of Things in Chicago that Charlie Catlett runs. But there are many other smart city projects out there. And so a test bed that you could use for, say, smart cities could be part of the infrastructure. Right? So this is highly distributed, but allows you to plug in sensors and so on. Actually, NEON, the National Ecological Observatory Network, when it was originally envisioned, was envisioned actually as an open system, so that others can plug in their ecological networks and so on. They've not got to that vision yet, but that's a possibility. So, for example, here's a grant that we just awarded under the Big Data program to a couple of PIs from Virginia Tech and University of Miami. They're creating this test bed for smart cities, and this last sentence here says, test bed is intended to be open access, will be able to support both research at the host institution as well as other users requiring non-proprietary multi-domain open data sets. So how do we facilitate things like that? So let me now just highlight a few of the things that would be part of this vision going forward. I already mentioned theoretical foundations and systems and so on. So just to dig a little bit more into that, NSF recently held a workshop on this topic of theoretical foundations of data science. There is a workshop report. You can get to the slides I can make available, so you can look at that. So I just pulled out a few statements from the report. Theoretical foundations are fundamental for industrial applications, scientific understanding. There's a demand for training students in this area. By the way, this workshop invited sort of one-third people from sort of theory people from computer science, but these are really sort of machine learning, algorithmic people. statistics folks, and math folks. So it was equally divided among those three communities, and it was sponsored by SAIS as well as the DMS, statistics and math division. So in a way, it's a group of theory folks, but it was very interesting to see the very pragmatic and practical issues that they highlighted as some of the key things that we have to address to do the theory. So data science is a broad discipline, covers everything from experimental design phase and data collection, all the way to data analysis and the inevitable decision-making phase at the very end of the data to knowledge to action paradigm. Okay, so it covers that whole life cycle. Theoretical foundations should have strong interfaces to application domains. And I showed you in the diagram, that's why you want to connect all the way to the apps so that the data is done in the context of some application. Interdisciplinary collaboration between theoretical computer science, math, and stats is necessary. Data provenance, reproducibility, privacy, algorithmic fairness are all fundamental topics. And then they also discuss a number of modalities by which these, if there were to be centers of this type, how could they be launched? And one idea was to leverage something like the Big Data Regional Innovation Hub. So maybe one more task for Leah to handle in their ample spare time. Okay, so that's on the theoretical foundation side. And these are a few things I made up on the infrastructure, systems, and engineering side. Right? So the infrastructure is about storage, it's about data, as I mentioned, and it's about the basic, what would be the data services, and that's the Hello World example I already talked about. And there are ideas like, it's not just queries to the data. You want to have multiple ways of interacting with the data. So you want to be able to do question-answer interactions. You want to be able to do dialogues with the system. Or you want the system to be able to do some storytelling with the data. So these are all sort of innovative ways in which you can have multiple interfaces to the same data. Right? And in this model, SQL just becomes assembler language. It's deep down somewhere there is SQL. Nobody's writing that. They're writing all these higher-level interfaces. Another idea was machine learning systems. And there's a meeting, again, I'll mention in the next slide, where we had some folks from industry, including the vice president for cognitive systems from IBM, so basically the Watson folks. And they were talking about how it's very important to think about how to build generalized machine learning systems, because really what's going on right now in the industry is verticals that are being built. Right? They're building a machine learning system for A, a machine learning system for B, a machine learning system for C, and they can clearly see the writing on the wall that this is not a scalable approach. And the cost of maintaining multiple vertical systems is horrendous for industry. Right? So they would really like academia to start talking about how do you build a generic machine learning system? What are the things that are transferable from one domain to the other that would help us build a more generic architecture? So that's this notion of machine learning systems. And then there are ideas like reproducibility. That's just one of them I put in. But I think we're only at the beginning of this reproducibility thing. I've been talking to some of the folks who do this, who've been doing this in their research. And people haven't fully thought through about how do you test reproducibility systems, how do you verify them. Right now, reproducibility systems will say, okay, look, I took all this stuff from this machine, ran it over there, say I got the same answer. But if I want to poke in and say, how did you get that answer? What happened behind the scenes? They're not there yet. So I think there's a lot more engineering and usability that has to be put into these things. Okay, so if we're talking about the data ecosystem, then there are lots of sources where data can come from. So we have independent researcher data, that's your typical PI with a data management plan doing something. And also you can think about this as NSF funding these things, right? So NSF funds independent researchers. There are small group databases. The community will get together and justify the need for a database in a certain thing. Stan mentioned open topography when he introduced me. So that's a project funded by NSF actually, that's for just airborne LiDAR data. So if you are an airborne LiDAR person, you'll put your data there, you'll come there to get access to data and do analysis of that kind of thing. There are certainly institutional level repositories. So yes, I was wrong, not all of this is NSF. The institution level repository would be non-NSF, maybe universities that have their own repositories, or regional networks might have repositories. And there may be large community data repositories. This is for maybe much larger use compared to the small group databases. That's actually the NCAR Wyoming supercomputer building, where there are petabytes of NCAR data, which is a large repository for many decades, right? Well, if I have all of these kinds of data, what I would like to do is, put a set of services that allow me to do discovery, access, integration across all of these kinds of data. Right? So I'd like to have an umbrella on top of this, and I think this is also part of that same vision. If you think about back to that picture of harnessing the data vision, you want to populate it at the bottom with all these different kinds of data, but then you want to have services that can provide you integrated access. So one activity we are right now that's going on that we are trying in this area is, could we create an open knowledge network? So a knowledge network is something that connects a number of entities together based on whatever relationships that might either have been discovered or defined or inferred, basically, right? So there's machine learning involved, there might be data modeling involved, but somehow you create linkages between things, and you create this network that shows the sort of semantic relationship between things that could then be used to answer all sorts of complex questions. Right? So we called this meeting, because we couldn't come up with any name for it, so we just called Entities, Facts, Questions, Answers. So that was the meeting. It was run under the NITRD, which is the interagency group. There's multiple agencies involved there. It was a small meeting, about 20 attendees from industry, academia, and agencies. So that's where we had the VP from IBM. We had a vice president from Amazon, who does the Alexa project. We had Vice President Jeanette Wing from Microsoft, a couple of ex-Google folks like Andrew Moore and Guha, and a few agency people and a few academics. Right? So the motivation for this was, we are definitely want to move, and we clearly are moving towards more natural interfaces to data. And as data gets more complex, you got to have easier ways to get to it. So it's kind of the paradox, right? And in industry, it's things like Siri and Cortana, which are all these interfaces that allow you to talk to a system and get you information back. So that's kind of the future that we are moving into. We want to have a networked data and information infrastructure capable of supporting integration of information from multiple independent, oftentimes disparate information sources, so that they can do question answers. Okay? And you want to have simple interfaces to that. And machine learning and knowledge representation can be instrumental in giving us access to these complex, model-driven, data-driven environments. So that was the motivation. So tentative idea there is, and that's just a tentative name, is to call it open, the open knowledge network. So can we create an open web-scale knowledge network to foster research and innovation on an entire class of new applications that leverage data, context, and inferences from data? Okay. So I'm down to my last few slides. Another area that's really important and is getting also a lot of attention in Washington, D.C., across the federal government is this notion of ethics and fairness. Right? As we go more and more towards data-driven, there's a tendency to just believe the data or just believe the machine conclusions from the data. Well, there might be biases in the data, there might be all sorts of problems in the data, and maybe you shouldn't be believing things that easily. Right? So how do you address this problem? For example, we just funded under the Big Data a project on algorithmic fairness, and that's Suresh from Utah, Sorrel Friedler, and Dana Boyd. And there was recently a workshop held on data responsibly that brought together computer scientists and social scientists. There's a new AI machine learning working group under the OSTP that is actually looking at this whole issue of AI and fairness. And, what would AI do to society? Those kind of issues. So I think the key idea here is, how do we embed ethics into education? And the only thing I'll say here is, I think there are ways you really need to make it integral to the coursework. It's not a question of saying, let's take all the curriculum that we have and just tack on one more course on ethics, and the kids will learn something. No, it has to be deeply embedded into stuff that you teach on the technical side. Okay. And my last slide, I think, is just to talk about some upcoming events and activities. We've just funded the National Academy of Sciences to run this workshop on envisioning the data science discipline from the undergraduate perspective. And it's CSTB, the Computer Science Board at NIS, but also the Statistics Board and the Board on Science Education. So what we want them to look at is step back and do some blue sky thinking that if data science was a new discipline, what would it look like as a discipline? Not how do I make it fit in my university, or how do I make it work on this campus. It's about envisioning the whole discipline. But as part of that would be if there's an undergraduate discipline in data science, then what do middle school, high school needs to have to do to feed into that discipline? And also, we think, at least I have a feeling that there will be a big role for community colleges in this. So what do you do for a 2-year program, both as a preparation to the undergrad, but also you might be able to get a 2-year degree and get reasonable work in the data area. Right? So they're going to address all of that. It's going to be a workshop followed by an interim report, followed by another workshop to finalize the report. We have another workshop coming up under the NITRD umbrella called Metrics for Assessing the Value of Digital Data Repositories, and actually Alan Deary again is leading it, and we are supporting him in that. And then next year we're going to have the Big Data PI meeting, which we had last year for the very first time, so this will be the second Big Data PI meeting, but this time we are combining it with the annual meeting of the hubs and spokes, and it might be around the February or so timeframe. That's it. And I'm open for any questions. Or,
Thank you, Chaitan. That was spectacular. So we have people listening through the WebEx and people in the room. We'll start with some questions here, and then Stephanie will signal us if there's questions for those participating on WebEx. If you're on WebEx, please type your questions in the box there so Stephanie knows that you have a question. And we'd like to create a discussion, so don't just ask questions, but offer your comments and thoughts on this. You can start responding to each other as well. So with that, first questions? Comments?
Yes. Hi, Jaden. Great talk. And I know that the focus here is on the technical kind of things. And thinking of your vision slide with the various layers and whatnot, it's not a stretch to call these socio-technical systems. And whenever we go to these workshops, they say, "Oh, the technical part's easy. The hard part is the social part." So to what extent is studying these kinds of interactions and facilitating community engagement to develop and use cyber infrastructure, is that in the mix?
right.
Repeat the question for those people on WebEx.
Okay, so let me just repeat the question. The gist of it is, what I talked about sounded a lot more technical. What about the socio-technical aspect of this? Because that always comes up front. And believe me, I know this. There are scars on my back. But I have a couple of different kinds of answers to that. One is, maybe the best answer is, as we think about this initiative, say harnessing the data initiative, I mentioned that we would like to do this with some applications in mind, right? So in the beginning, you don't want to take on all applications just because I have a practical project. So we might work with a directorate or two to say, okay, let's take those applications. And I think in that context, we should definitely worry about the social aspects of that particular domain. Okay, that's one answer. The other thing I would say is I don't know. I feel like we know this now. I mean, this is something we didn't know 20 years ago that we are going to run into this buzzsaw. But I think we kind of know this now, so hopefully we're not going to make the same naive mistakes we made before of ignoring it. And actually, in that context, I want to mention that one of the projects that we funded, David Ribas at University of Washington and Jeff Bowker at UC Irvine, have been funded to do a sociotechnical evaluation, ethnographic study of the hubs and spokes for exactly that reason. Because let's not be glib and think this is all going to be successful. Let's have some social scientists observe us, kind of thing, and tell us, hey, this stuff ain't working, right? So yes, we are aware of it, and I think basically to summarize again, we are aware of the problem, and one way to do it is bite off a little bit at a time. So work with few communities and be aware that there is the social aspect.
There's a question online. What about the trustworthiness standards? Did I miss that as a cross-cutting concern on your stack slide? And that's from Mary.
Right. So thanks for that. So you already, do I have to repeat it?
Yeah, if you could repeat it.
So it was basically about what about trustworthiness standards? So thanks for that question, because we talked about exactly that with Reagan before the talk, and I really liked that discussion we had, which is that Reagan has actually looked very detailed at an ISO standard for trustworthiness, which has something like 200 or 600?
No, it only had 113.
113 criteria. So I think in the context of harnessing the data, you really want to think about that as a research program. It's a bigger research program. Hopefully it fits into that gap that we talked about between the $20 to $200 million, right? So maybe it's a $50 to $70 million research program. We don't know. But it's a big research program, and so in that sense, the trustworthiness at one level is not an issue because our research is working on it. On the other hand, you might say that's a good test bed to try something on trustworthiness. So I think what I would say is, yes, I think it's about time for us now to think in quantitative and very specific ways about trustworthiness, and these ISO standards or other methods may be something to use. But as we had the discussion even before the talk, this could also be a highly it's a bit of a complex issue, because what's trustworthy in one case may not be trustworthy in another case, or even if something is not so trustworthy, you might actually want to use it because it's the only thing you've got. So understanding all those is a bit of an issue. But yes, it is important. Stan.
So I'm really interested in a number of questions, but the one that just jumps out at me that I have to ask the thinking behind it is this idea of data science as a discipline.
Yes.
Because right now I think data science is viewed by many on many campuses as an integrated solution, and I can't think of any better way to get everybody riled up than to talk about a new academic discipline. In academia we don't change quickly, and computer science is what? How many years old? 55?
50, 60 years old, yeah.
Yeah. We have one of the oldest computer science departments here with Fred Brush. And that was highly controversial and probably still being argued about on this campus. I wouldn't be surprised. So how did this thinking come about? That's an interesting proposition.
Yeah, because we want to be in your face. So the question is, data science as a discipline might be a controversial thing, or maybe not something that every campus might embrace. The thinking was, we work very closely with our statistics colleagues, I have to say, at NSF. So size and stats, we are having a lot of discussions on this. So for example, our stats people are approached almost every day, I'm told, by statistics community in academia, saying, why don't you just declare that stats is data science? Okay? And there are some statistics departments that have changed the name to data science. Okay? And our own statistics people will say, well, because it ain't. Right? That's not data science. Data science has all these other things as well. Right? And I think in computer science, I would say, data is only one part of computer science. And there's a lot of other computer science that's happening and will continue to happen, whether you guys believe there's a CS discipline or not. Sorry, not that. So that's why I put that box with all the things that you have to think about when you think about the end-to-end data lifecycle. It's the theory, it's the modeling, it's the data management, it's the algorithms. Now, where is there one program that gives you all of that, right? So we purposely, for the sake of this workshop, said let's not get into this hassle of people saying, okay, I can take these 2 courses from here and those 3 courses from here and create a data science. Let's just step back. So that's why it's a visioning blue sky kind of exercise. If you step back and just talk about by the way, we do have some trepidation here because we are not sure if we can get the right kind of people from the community, because we feel like so we're trying to, as best as we can, have some dialogues with our NIS colleagues that make sure you get the right kind of people who are willing to think about, just for the sake of the workshop, that there's a new discipline, rather than saying, well, where will I teach this and how will I get credits if I teach in that guy's department and stuff like that. Right? So it's just like stepping back and saying, what if there was a data science discipline, what would it be? That's what the exercise is. Now, people can take different lessons from the report. Right? The report will come out and people will say, well, that maps in the following way to my campus. Or somebody might say, you know what, this is great, I'm going to start a new data science department. And there are also other countries. I was just in India a few weeks ago, and people are everywhere are thinking about new things, and departments might start elsewhere as well. We don't know. But yeah, I totally get it about the speed at which academia will move.
Yeah, actually, continuing with what Stan said, like NSF used to have the ACI as a separate thing which is cutting across.
OCI.
OCI, sorry, yeah. And will there be a ODI, which might be?
That's a mean. So the question was, NSF used to have OCI. Will there be an ODI? That's a mean question because that shows that even NSF moves very. So I was joking with my colleagues that actually I still can't figure out exactly how. But if you carved out IIS and maybe some parts of CNS and CCF and the DMS division within MPS, so you could possibly make a new directorate of data science. I think I would be out of NSF before that happens. I have one more year.
Or because.
Yeah. Yes.
You mentioned generic ML systems that cut across domains. Can you share a little bit more about your plan on how to do that, since there are existing ML libraries, open source libraries, and things like that? Are you going to leverage those? Or?
Yeah. I mean, so the question was about the ML systems that we talked about, and what would be the plan to how to go forward.
Mostly around how to make them generic.
How to make them generic. I don't know. I mean, right. So I think that's really where the research issue is that could you build some kind of a generic framework in which you could slot in some of these algorithms. So the framework might say, you do this, followed by that, followed by this, and now there are different algorithms for doing those things. Where it comes from is actually what our colleague from IBM mentioned in our meeting. They said, if you look at Watson for Jeopardy, it was a system that was built to play Jeopardy. Right? Then they took that and they created Watson for oncology. That's a system for doing oncology. It says Watson. It's actually a different system for doing oncology. Now they took some of the same engineers, some of the same experiences, but what they found is they had to do a lot of things from scratch. Now they're doing Watson for insurance industry, Watson for aircraft industry, and their frustration is they're having to start from scratch for everything. And in fact, it was the industry people who said, and the Amazon person there also agreed, who said, there's got to be a better way than this. Right? There must be some more systems way of doing this. So to me, it's an open question how you would genericize.
I mean, your last comment kind of struck me as reflecting something that I know already. I'm a domain expert. I pretend to be a data scientist once in a while, but really I'm a domain expert. And the hard part about doing the work that I'm interested in is NIH, who is usually often the source of my data, does mandate data sharing. But the problem with the data is the metadata hasn't been captured to allow a non-expert to use the data realistically. And as an example, I could just make it, so I'm a physician, so I could say, we could have a data point about people's weight, okay? Actually, weight isn't uniform anyplace. Does it mean your lightest weight in the day? Does it mean dress? Does it mean with shoes? It means all these things, and that metadata is routinely lost. And in fact, I would go as far to say as one of the major sources of data for genetics is dbGaP. And in fact, the loss of metadata is intentional by the people that submit the data because they don't really want other people to use it. I mean, that's a cynical, provocative statement, but it's not far from the truth. And so, the role, when you talk about needing to rebuild Watson, it's because that domain expertise wasn't there in the design. And so I'm curious if you have thoughts about how to, bring in the expertise of the domain expert to data science and how you would, capture the metadata that's required to be realistically used data.
Right. So I guess the question is about how do we bring in domain experts to help with the data science process and systems. and capture the metadata as well. Well, so that's also some discussion we had earlier today. It's clear that capturing metadata is going to be essential, and it's interesting actually. One could argue that we haven't fully explored the whole space of metadata and data across all these different applications, because you can easily come up with examples where for just one piece of data there's a humongous amount of metadata that has to go with it. And there may be other cases where data doesn't need that much metadata. So there's a whole range of things, and that just understanding what is that range is one, and also understanding what kind of processing can I do with the data given that I have this metadata. Right? So actually, the way I would say that's captured in some sense is, anyway, one of the words I had there was context dependent. And that's actually, I think DARPA has a new program on context-based learning, I think they call it. And that's, in a way, falls under all of this. The context, metadata is part of that context. And I think we need to now build learning systems that take the context and the metadata into account. So that's one answer on the technical side. The domain science side, I agree. I mean, I think that's exactly how we want to make progress. That's why when we do these kind of exercises, we should do it with the domain folks. Right? So whether it's biologists or ecologists and so on. And I think we need to understand this as a system to say, okay, how do we take what we learn from these guys and see which part of it is general, which part is specific to the domain. Because this is another of those things which I'm sure people like Regan, Raja, and others have experienced. When we go to domain folks like you and talk about things, every domain person will say, I'm unique. Right? My problem, nobody else has the problems that I have. And when you go to them and say, no, actually, you're not unique. I've seen this problem elsewhere. They don't like to hear that, right? So you develop this method of saying, yes, you are unique, but let's solve your problem, and then you do something more. So it's that interaction that needs to happen. So I think the answer is you got to have projects and vehicles by which the domain folks continue to interact with the technology folks to develop these kind of systems.
I would argue that the metadata is what distinguishes the domain expert for understanding it. But
the understanding of the metadata.
yeah.
Well, that's a good point. Yeah, which is the context, understanding the context, which goes back to some of the earlier things I said. We have all these situations where sometimes this data is good enough to use in an analysis, and sometimes it's not. Well, as a technical data science or computer science technical person, you don't know that. That's very domain specific. Now, maybe you could say you could learn that over time by observing what's done. But initially, it has to be the domain person who says, look, right now, that's all I got. It's okay. Let's use this. Right? But then there's a metadata there as well, right? When I do the analysis with that data, I need to capture that that's what I did. So that downstream processing understands that processing was done using that particular constraint.
Jay, we have a question online. If I can bring this over here so I'm closer so you don't have to repeat this because it's a
Okay.
long question. So Jim Beach asks, the quality of commercial applications and user environments is increasing and accelerating in their usability and user experience. For example, you mentioned Siri and Cortana. Applications deliver the value of data science repositories and integration to science stakeholders. Yet science domains are highly constrained by grant funding levels to deliver nimble end-user applications to researchers and students. Where would the resources come from to take the value of the infrastructure envisioned to implement and sustain it as a translational (open source) applications, which are extensive and require external funding to maintain and support? Or how can that large financial barrier be lowered to deliver the value of our vision to science domains and communities?
Well, thanks a lot, Jim. Hi. When going back to the spoken meeting that we had, the whole idea started exactly because some of the folks from the community came to us and said, just as we were falling behind in the cloud technologies, it looks like the academic community is falling behind on the knowledge network technologies, because Apple has its knowledge network, Amazon has its knowledge network, Google has its own, Microsoft has its own. So the discussion was, look, either we should try to create something that's open and have an initiative in this, or we basically just lose the battle to these guys. So we said, okay, let's get together and see what could be done in an open forum where industry could help, right? But academia can at least do work that's comparable to what's going on out there. And as I mentioned, we were able to attract very good people from industry as well, and they were all very supportive of the initiative because they see the value of academia doing things at the same level that they're doing things, so that people that we train can then basically go and work for those folks. So I would say the way to do it is to actually embrace the way industry is doing some of the things in these areas. And I have a sort of personal bias. I mean, I have industry experience, and I tend to think that some of the things done there are pretty cool. So I think it's not that academia has all the answers. So I think it would be good to get engaged with industry to do some of these things. And my own feeling, this is very preliminary. We are still in a lot of discussions with vendors and so on. But let's see. It's possible that industry will help us in some ways in getting there. Right. The question of resources, I hope you know who your local congressman and senator is. I mean, I come from California, where we can't even see where our senator is. It's a huge state. But clearly in North Carolina, you have very close connections. And I think you should go and ask them to put more money into science. I think as an NSF employee, I'm not allowed to say that. So actually delete that last statement.
Actually, this brings up the question about, you had those triangle diagrams where translational data science is in. Does NSF want to put money into that one or not?
Yeah, so the question is, does NSF want to put money into translational data science? So, that is something I made up, I put up. But actually I found out, again, as I say, I was at University of Chicago last week, and Bob Grossman there has a group, and actually if you go to his website, it says what they do is translational data science. So there are some people who have picked up that terminology, maybe especially in the medical school, because they've seen translational medicine as a concept. In a way, you could argue that NSF has done it. They haven't called it that way. The ITR programs were kind of like that, right? So I think yes, more of the ITR style things would be good to bring.
Because NIH
whether we call it,
NIH does it, but NSF doesn't.
NIH does translational medicine, but why doesn't? So I think that's a great question, because if we really think of data and data science as this sort of mega powerful weapon thing that we have, tool that we have, then we translating, leveraging, using that tool to solve some real problems should be a sort of a heavyweight activity, right? Not just something you just do in a very transparent way.
Yeah, because it's not foundational. I cannot go and ask for money. I don't get any money from that. Right? So that is the reason I'm asking.
I kind of want to follow up on Raj's question, because I can imagine being enthusiastic about writing a proposal that would utilize IBM Watson's cloud infrastructure and attacking Kurt's problem, but we're going to try to figure out how to build a Cortana, only it's Watson, for genetics. And we've got lots of data, okay? And really making a stab at that. But whenever I think about this, and I'm being very provocative on purpose, Peyton, I think of the experiences I've had in panels, and it's a bunch of computer scientists or a bunch of electrical engineers or whoever the heck it is, and they're going to go, "That's not new. That's just using other stuff." And I got zero chance. So why? It seems to me that somehow we have a sociotechnical problem that we need to figure out how to get around. Because I agree with you. I think that a huge amount of the rewards, impacts, are going to come from translational data science, and yet we have no patterned behavior at NSF, and I'll just be very provocative, that would allow us to actually think about going and finding money. At NIH, it is slightly different. They do have patterned behavior that heads you in that direction.
Yeah. So again, well, that's a long one. Quickly repeat. Let's see. It's about supporting translational data science. Is what your question is?
Yes.
At NSF. Well, I totally agree. So I think that's what I feel, is that we are entering a new era. And you can imagine, at the highest level, you can think of this as an organization like NSF recognizing that this change is happening and saying, okay, that's a real bona fide activity. And I think that's the advantage of giving it a name, because then the people who do it get respect. So you actually recognize someone saying, wow, you are the translational data science expert, right? And then you can have programs. Now, whether it happens or not is way above my pay grade. But I think that's why highlighting that as a thing is going to be important. And actually, you talked about reuse. A couple of quick things there. I think one of the scopes that we just funded, the big data scopes, is actually using Watson with the Encyclopedia of Life, EOL database, and actually doing exactly the kind of Q&A things I mentioned with EOL. I forget who I think it's at Georgia Tech and some other university.
Emory? Is that the one with Emory?
Not Emory. We'll have to look. So there is a spoke exactly in that area.
Okay.
And the first time I actually mentioned this concept of translational data science was actually at the Big Data PI meeting last year. And in that slide, I had a thing which said CI reuse. So I don't know how many of you got funding under that, but there used to be a program under OCI called CI reuse. And I got some money out of that, which was the concept that if you build some cyber infrastructure in one project, and then you are saying that I want to take that and use it in some other project, there was actually a pool of money they could give you to do that. So these kinds of ideas.
Because that's the only way to make the CI really good in the long run, is use it over and over.
Exactly, we know that, right? I mean, one shot is not going to be the thing. You have to iterate on it.
So
you have classic examples of
is CI
SRB
reuse
and
still
IROs.
there?
Sorry?
Is CI reuse still there?
No, it's not there.
Because I have a couple of projects I can do.
Yes.
Is there a change in thinking on software maintenance and upkeep? You're talking about a large stack of cyber infrastructure, which is, obviously hardware, but there's a layer of services across the top of that are going to need to be maintained into the future. How do you see all these things fitting together in a long-term strategy? Because you're talking about open source where code is going to need to be maintained, and infrastructure that's going to need to be maintained, and all of the funding from what I've seen is for new science or new engineering, and you're never going to be able to compete with companies like Facebook and Google without being able to write software that is maintained and supported.
Right. So the question is about software maintenance and support and what to do in the long run. So I think the kind of big ideas we are talking about here are research ideas. So they fall under the category of typical NSF research programs, right? So we may be putting forward hardware, we may be putting forward software, but it'll all be in the context of research.
Mm-hmm.
Software sustenance right now falls under, there's a program called SI2, or S2, Software Institutes.
Right.
That's where you would go if you had software that has been community adopted. Because this here, let me not say that. So okay, so if you have software that you've demonstrated that a community is using and has adopted, and that you need to maintain it, there is a separate program at NSF. So that's
Okay.
all I would say. Yeah.
I find it frustrating that I see a lack of an amplification effect, where you're doing whole new research here and whole new research here, and none of these parts are designed in a way that they can fit together in that stack, to overuse the term stack again, so that the next new thing that is done is considerably easier down the road.
Right. Well, so that is the hope with certainly this kind of program. They're harnessing the data program. The hope is that by creating this whole stack from hardware up through the applications, that we will create some initial set of capabilities, services, software.
Right.
The hardware may come and go. That could then translate either through other. And what is the vehicle for that? It will have to be through other programs. So suppose you created a set of services that were really cool, like say Watson talking to Encyclopedia of Life. Then the biology directorate might say, wow, that's something we want to continue to work on. At the end of the day, it'll all still be fundamentally about research, of course, right? Because NSF is not really there to stand up long-term infrastructure. But there may be a longer-term life to something that you create under a program like this if a particular science area picks it up and says we want to sustain it. And again, like I say, one way to sustain it is through the software program that ACI already has. Or it could be through a directorate that says, I mean, Geoscience Directorate, for example, supports a lot of hardware and software as a directorate because they find it in their own best interest for their community.
So we have time for 2 more questions or comments.
Yeah, so just there's another spin on Jason's question, which related to software, but it's the reproducibility side and making software a first-class object like data that needs to be preserved and maintained along with the data. Is that something that would be in this context?
Yeah, so the question is about software being a first-class object like data for reproducibility and so on. I would have to say that's already there. I mean, actually, if you look at the data management plan for the big data research program today, it actually has explicit wording about what you need to do about the software, which actually was taken from the software program. I think that Dan Katz or somebody actually created it originally. So there are, and it's been used by multiple programs. So at least there's a recognition that software also needs to be treated like data in terms of keeping it and so on. The reproducibility is a different question. In fact, let me mention it. Actually, this is something I'm very interested in. So everybody talks about reproducibility, but when do we actually do it? When do we get to do it? So I've been thinking quite a bit about what could be the role of, say, NSF, or funding agency, to do this. And I've talked to some folks. It's still very half-baked ideas, but it would be interesting if we could provide some kinds of incentives that make people do reproducibility. And actually, it's what somebody from the community told me is rather than incentives, you make it in some sense a disincentive. That is, rather than saying if you produce a reproducible result, you will get an award, you say if you don't produce this reproducible result, you won't get all your money. So anyway, whichever way you do it, I have a feeling unless either journals or somebody like that needs to insist, or maybe somebody in your department needs to insist that, but I don't know how they would do it. I think if journals insisted, then at least in your department they can say, how many reproducible papers did you publish? Let me take a look. Right? So there is something that could be done there, but not sure exactly how to proceed.
So my question is related to the generic ML question earlier. So one thing I want to mention is Google is already doing like the deep mind. Like it seems like they're already doing something in generic machine learning. And so my question is, because all these commercial entities, they have their commercial interests to protect. So when they do those research, they're very secretive. But as universities, we're very open, right? When we write proposals, we want to be able to say, okay, we want to try to do something new. We don't want to compete with Google exactly. But how do we know that Google is not doing exactly what we're proposing to do, and thereby kind of wasting resources if the project is.
Right. So this is a question about how do we make sure that we are not duplicating what maybe a company is already doing.
Yeah. Even if there could be like, how do you foster collaboration between the industry and.
Okay, that's a different question.
Right.
So the other question is, how do we foster collaboration?
Two questions.
Right. And actually that came up in our token meeting as well. Mm-hmm. It was actually the Microsoft person who said, who actually raised this issue saying, look, there are proprietary knowledge networks within our companies, and we should think about how we might interact between the open and the proprietary. We don't know what the answer is, but they're open to thinking about such things. I don't know, the answer to the other one is, well, if it's proprietary and nobody knows about it, the tree fell in the woods, then nobody heard the thing. So we don't know that it happened. However, I think it's not just about general machine learning per se. I think we are talking about building systems that are general. So if you have a data system that is doing the X problem, Jeopardy or oncology, whatever, that system may be doing a bunch of things. Maybe it's doing data cleaning, it's doing data structuring, it's doing some supervised learning, a bunch of things. So you would like to look at all the stuff that it's doing and see how could you generalize that and take it to the next level. My understanding is that's one level at which you're talking about building machine learning systems, not just at the algorithmic level, but also at the system.
With that, I'd like to thank Dr. Chaitan Baru. I'd also like to thank Carl Gustafson and Stephanie Suber, who have so wonderfully handled the logistics for this meeting and handled the live WebEx. Also thank those of you who are on the line and have sat through this remotely. We will be hosting these monthly. If you would like to serve as a presenter, panelist, or would like to host one of these data science roundtables for the South Hub at your institution, please let me know. For those on the WebEx, I did type in my email. Also, the South Big Data Hub Infrastructure Working Group will be Friday at 3 o'clock. Carl has so kindly, in coordination with Regan Moore, organized a series of demos. So we'll be doing 1 to 2 demos each week or every other Friday from now in the next couple months. So with that, thank you all. Dr. Chaitan will be staying on will be staying on for the next hour if those of you would like to continue to talk with him. Thank you.